Hello everyone, welcome to the strings tutorial. We will start with a new NanoUI project. Save it. A string is a sequence of characters. There isn't any program that doesn't need to deal with strings in some way. String literals, we've already seen them. So I'm declaring a variable of type string and setting it. The hello world section is a string literal. A string is an object. It has all kinds of methods and properties, and we will soon go over the more common methods. There is a special operator reserved for strings. This is the concatenation operator. For example, and we can see the result over here. Let's go over some of the more common tasks related to strings. So we will start with printing all the string characters. The length property, the length method actually, returns the number of characters, and like everything in before_x, it's 0 based, so we need to count from 0 to length -1. Char it. Let's run it. And you can see the result over here. Trim is very useful if you want to clean the user input. It can always have extra white space, so we want to remove it. You can see in the logs. Note that all the methods return a new string. They never change, never modify the current string. We will talk about it later. Strings are immutable. So calling the trim method doesn't change anything. We must assign it back if we want to use the trimmed string. As you can see over here, on this line it still points to the original non-trimmed string. Let's see how we can parse the string and find and split it into the two words. We'll find the space between the words, index of space. It will return -1 if that character wasn't found. In this case, we know that it will find it. First word, substring 2, starting from the first index and up to I. Note that the end index is excluded. Second word. In this case, we can use substring, not substring 2, and this substring takes the string from the given index and up to the end. In this case, we want to take I plus 1 because we want to skip the space. Let's see that it is working properly. Run it. And you can see the result over here. We can use the char keyword to get the character that matches the given Unicode point. Unicode point is similar to ASCII, unlike ASCII, which is limited to 127 or extended ASCII. The Unicode points cover all human languages, and it is much broader. Ciao. And we can run it. And this time it's a small symbol, small and unrecognized symbol. Let's print the Hebrew alphabet. For this we will use the ask keyword. It converts, it finds the code point from the given character. Test it, and we can see the result over here. In many cases you would want to use regular expressions to parse or to split a string. I'm not covering regular expressions in this tutorial. I recommend you to search for regex in the forum. There are you'll find several tutorials. Just as an example of a common usage of regex, let's say we want to split it. regex.split. In this case the pattern is simple. It's space. And we'll run it. Now let's say that there were dots instead of spaces. So we are optimistic and we just change it to a dot. It doesn't work because a dot is a special regex character and we need to escape it like this. And this time it works. Our next topic is encoding. Encoding determines how an existing text is converted or represented as bytes, and vice versa. We need to know the file encoding in order to read the text correctly. I'll show you some examples. I will use the byte converter library. Now to convert a string to bytes, we call the getBytes method. I've declared an array of bytes variable, assign it as getBytes, and now we need to decide which charset to use. Let's start with the simplest, ASCII. And to print the result, I will use hex from bytes. This is a method of the byte converter object. Now we will do another example. This time with UTF-8. UTF-8 should be the default charset that you use. And again, run our program. You can see that the result is the same. For compatibility, UTF-8 uses the same representation as ASCII for all the characters supported by ASCII. However, if we change the string to a non-ASCII character, for example, Hebrew characters, you can see several things. First, ASCII returned an incorrect, invalid value. I'll show it in a moment. Second thing that you can see is that the UTF-8 encoding is now longer because some of the characters are now represented as 2 or more bytes. Now let's try to convert the bytes back to characters, back to a string. This is done with the bytes to string method. Now we can see that ASCII encoder has failed to encode the Hebrew characters correctly, while the UTF-8 encoder handled it properly. As I previously said, UTF-8 should always be the default encoding you use, and if you are trying to read a file and it doesn't read non-ASCII characters correctly, then you are using the wrong encoder. Reading a text file is done with file read string. This uses the UTF-8 encoding. If you want to choose a different encoding, then you need to do some more work and use text reader. Note that in B4I you need to use file read string 2. Now here we will open the file and enter the non-standard encoding. As a programmer to a programmer, I recommend you to never use Windows Notepad when you work with text files. You should use a decent text editor. I highly recommend Notepad++. The standard string literal is limited to a single line. Now, if we want to add another line, we can write it like this. CRLF is the new line constant. Note that it is not really CR and LF, line feed, carriage return and line feed characters, but on most platforms it's only line feed. Or we can also use the continuation character and write it like this. As you can see here. However, it is quite limited, and if we have longer text, it will be cumbersome. We can instead use the smart string literal. Let's see an example. Smart string literal starts with $and a quote and ends with a quote and a dollar. The smart string literal is not limited to a single line. As you can see over here, note that the tabs are included in the string, so it is better to write it like this. Now the smart string literal has other advantages as well. We can put quotes inside the string. We don't need to escape them. This is very useful if you want to embed JavaScript or HTML in your code. Another nice feature is the string interpolation. And now we want to put those variables in the string, so we can write it like this. Which is quite annoying. Or we can write it like this. Let's change it to a double. Now the result doesn't look good, so we want to format it. We have two choices. We can use the number format keyword, or we can add a format modifier inside the smart string literal. Let's run it. As you can see over here, the integer part is the minimum number of integers, 4 in the first case and 1 in the other cases, and the fraction part is the maximum number of fraction digits. Second option, using number format or number format 2, this gives us more options. And whether to use grouping or not. By the way, you can combine both options like this. Other format modifiers. You can see them over here. Date. Time. Forgot to log it. Next topic. Strings are immutable objects. You cannot modify an existing string. You can assign a new string to the string variable. Now, in most cases, you can ignore this fact. It makes working with strings easier. However, if we have code such as this one, we want to concatenate all the numbers from 1 to 10,000. Now let's see how long this operation takes. Should always check performance in release mode. And it took 200 milliseconds. 200 milliseconds is a heavy operation. It took so long because it created a new copy of the complete string every iteration. We can improve it by using String Builder. String Builder is a mutable string. So it has all kinds of methods that change the represented text. And eventually we convert it back to string. So previously it took 200 milliseconds, and now it will take 12 milliseconds. 10 times faster. And if the number of iterations was larger, then the performance gain would have been even larger. We have a string, maybe it's user input, or maybe we read it from a file or some other way. Now we want to convert it to a number. This is called parsing. As you can see in this code, we don't need to do anything special. We don't need to do anything special. The compiler sees that we want to convert the string to a number, and it will parse it automatically. Run this code, and it prints the correct value. We can also write it like this. It will also work. However, what if the string is not a valid number? Now there is an exception and the program has crashed. So if we are working with user input, we always need to validate it and make sure that it is actually a number. We can catch this error like this with a try catch block. It will work. Or better, we can use the isNumber keyword to check the string. The other way is simple. We want to convert a number to a string. However, if we are working with floating points, we should explicitly format the string, use a number format 2, or the smart string literal. Otherwise, the result will depend on the specific number. Tip: don't use round 2 for formatting purposes. You don't want to lose the accurate number. You just want to format the string. Round 2 will truncate the number and the precision will be lost. There are several popular text formats. JSON and XML are two very popular formats. Overall, they are pretty simple to work with, especially JSON. Don't try to create a JSON string or to parse a JSON or XML with the string methods. There are libraries for each of these formats, and they will do it better and more correctly. That's it. As always, you are welcome to join the forum and ask any question over there.